Yeah. Yeah. Good evening, all. So myself, Vijay, I hold like 15 plus years of experience, right? Which includes nearly 8 plus years of experience in big data environment like Hadoop and Spark. So as part of today's demo, just I'm going to cover the following topics. But before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, sir. We can able to hear and I can able to see.
So, okay. So first, what is Apache Spark? Why PySpark? Need for PySpark. So most of them have got the query, right? Yes. Why we need to go with PySpark, Spark with Python implementation or Spark with Scala implementation, right? Like, so whenever I say like Spark versus PySpark, so Spark means by default it uses Scala language, and Spark, PySpark like Spark with Python implementation. Spark and PySpark, right? Spark with Scala. Otherwise, like you can say like Spark Python and Scala, right? Yes. PySpark features a real-time usage of PySpark. Yes. PySpark job market, right? Yes. Okay. So what is Apache Spark? Why PySpark? Need for PySpark, Spark Python versus Scala, and PySpark features, real-time usage of PySpark, and PySpark job market, right? Yes. So what is Apache Spark? Apache Spark, right? I can say it is a open source distributed cluster computing, right? Apache Spark is a open source distributed cluster computing framework introduced by Apache Software Foundation. Open source distributed parallel processed cluster computing framework which was introduced by Apache Software Foundation. So I can say it is a Apache Spark. This Apache Spark is a general engine for big data analysis, right? It is a general engine for big data analysis, processing, and computation, right? So this mainly used for, right, for data analysis, big data analysis, right, processing and computation. So okay, more on this I'll be discussing that. But why PySpark? Why PySpark? Okay, PySpark, I can say it's a Python API to use Spark. Python API to use Spark. Spark, I was saying that it's open source cluster computing, which is used for big data solution. So I can say PySpark is a lightning fast technology, which is designed for fast computation. PySpark is the very demanding tool among the data engineers, right? To work with bigger data sets. If you want to work with bigger data sets, right? So yes, if I say why PySpark, and PySpark used for, right, just observe, it is used for distributed SQL, for running distributed SQL, right? creating data pipelines, right? Yes. Ingesting data into database, for ML algorithms, for graphs and for graph or data streams, right? So it's used for distributed SQL, for creating data pipelines, ingesting data into database. Mostly, like as you see the PySpark major, you see in ML algorithms and graphs or data streams. So you are saying like, what is the need for PySpark? What is the
distributed SQL?
Need for PySpark? So here, if we talk about normal SQL, and here if you see Spark SQL, right? We got the concept of data frames concept available. We have got here data frames. See, huge data is there. The huge data, just you are going to process it, and you are going to make it like a structured format and create a data frame, right? Your data is distributed across multiple systems, right? Multiple systems. See, if the main advantage of Spark, see, as compared with other technologies, right? Very high speed processing, right? So your data is going to get distributed across multiple systems and are processed parallelly, right? So here your data is getting stored not within the disk level, memory level, RAM level. That's why we say in memory computation. Spark is a in memory computation technology, right? Because data getting stored within the memory level, data getting processed within the memory level, a bigger data sets, bigger data object divided into multiple parts, partitions we say, and stored across multiple RAMs of multiple slaves and are processed parallelly. So here we are going to create, after that we are making the data structured, creating data frames, we have got many data frame APIs. Later we can create the data frame register like temp tables and perform pure SQL kind of querying, right? So bigger data objects, if you want to query, right, which are got distributed across multiple machines, creating data frames and performing querying, right? So this kind of distributed things you can see within this, means querying, this kind of querying you can see in this PySpark. And Spark is a data flow language. It's a data flow. Spark is a data flow. Data flow means you can see pipes, means it's a collection of pipes. Means you got the output of one will be the input to the next one. The output of one will be the input to the next one. Data flow is nothing but the first, that output of one will be the input to the next one, next pipe. So creating data pipelines, ingesting data to database, ML algorithms, and for data graphs or data streams. And need for PySpark here. Need for PySpark. So if you see today, large amount of data is getting generated both in offline and online, right? You see large amount of data generating offline and through online. So these data contain hidden patterns. They contain hidden patterns, unknown corrections, market trends, customer preferences, and other useful business information. It is necessary, right, to extract valuable information from the raw data, right? So we require more efficient tools to perform different types of operations on this huge data or this big data, right? So there are various tools already. We have got various tools available. I'm not saying that we doesn't have tools, but there are various tools to perform these multiple tasks on the huge data sets. But these tools are not so appealing. So it is required that we needed some scalable and flexible tools. We need some scalable and flexible tools to crack this big data and gain benefit from it, right? So PySpark is such a kind, right? So, so for this, what we do, combination of Python and Spark will be the very efficient for the world of big data, right? So I'm combining both. We are combining Python and Spark, where Spark is the execution model, Python is the language combinedly, right? It's efficient for the world of big data. That's why Apache software community, right? Apache software foundation or community, right? Yes, it came up with Apache Spark. So it's a technology, right, for a very high speed processing. Came up with a tool called PySpark. That is Python API for using Spark. Okay. So most of them have got queries, right? Whether to go for Spark with the Scala or Spark with Python, right? So both has got the equal demand in the market, right? Depending upon the requirements, right? But if you see that Spark can be coded, Spark can be implemented by using 4 language, not only Python and Scala, right? Python, Scala, Java, and R language. Spark can be coded with Python, Scala, Java, and R language, but mostly used ones Python and Scala by default. Spark built using Scala. Spark built by using Scala. Scala is the native language of Spark, right? Spark, but these days, if you see, even Python is mostly used or preferred, right? Where Python is used as a language, where Python has got huge libraries, many libraries for different mod. It has got different modules for different environments, right? Especially for machine learning, or if you see for graphs, not only S for SQL kinds of queries also, right? Even we have got Python has got some modules like pandas modules, right? So just if you see the difference between Python and Scala, just observe this. See Python and Scala, right? Yes. Python, Scala. Python is dynamic typed. Dynamic typed. Scala is static typed. Dynamic typed means here in, if you say x equal to 10, based upon what value you are assigning, the variable x is going to get created dynamically. Here we don't need to say like int x or float. Okay, in this way x equal to 10 or float y equal to 4.5, right? Here no need to say like based upon the value, what value you are assigning. Based on the value assigned, the variable x is going to get created dynamically. Y equal to 4.5 means float value, right? A float value assigned to y. What value you are assigning to x, what value you are assigning to y, based on the values assigned, the variables are created dynamically here in Python. So but Scala is static time. Okay, but so Python is a huge community, right? Python it has a huge community. It has smaller community, right, as compared with Python. So Python has got powerful libraries. Python contains powerful libraries. Powerful libraries for machine learning, for ML, machine learning, for graph algorithms, etc. Right? Yes. Scala also contains, Scala also has got libraries. Scala also has got powerful libraries, but as compared to Python, right, little less compared to Python. Less as compared with Python, as compared with Python. So nearly 89,300 inbuilt features a library, inbuilt modules Python has got for different domains, right? But less as compared with Python. The mainly thing is powerful libraries for machine learning. See, if you want to go for any machine learning kinds of activities, better go for Python. That is Spark with Python, right? Yes. PySpark features. PySpark features, right? Yes. First, the main feature what we see in memory computation. In memory computation. In memory computation, because of which it has got a very high speed, right? So here your data object, I said your data object is going to be divided into multiple partitions. Partitions are distributed across multiple systems into multiple RAMs of multiple systems and are processed parallelly, right? Yes. In memory computation, this even you won't see in Hadoop. Yes. Second, lazy evaluated or lazy evaluation we see, right? Lazy evaluation we say. Active evaluation or lazy evaluation, right? So which is better means lazy evaluation only, right? So on demand we can execute, right? On demand, right? Executing that, nothing but lazy evaluation means. So whenever required, you can just execute it, just like a function call, right? So whenever function, you will define function, whenever required, you will be calling it, right? At what time or how many times you want that. So when required and how many times you want, you will make a call. In the same way, lazy evaluated means you will define the flow, you will define the data flow. When you perform some kind of action, only your data flow executes, otherwise it won't execute. Lazy evaluation nothing but whenever you define the data flow, whenever you make some kind of action, whenever you trigger an action, then only your data flow gets executed. Until then it won't execute. Yes. Lazy. Active evaluation means immediately when defining, execution. Whenever you define, immediately executing is nothing but active evaluation. But here lazy evaluation means until you perform action, it's not going to get executed. Fault tolerance. It has got powerful fault tolerance model, right? You have got fault tolerant. So I was just saying that, just observe this. Your data object divided into smaller partitions. It is divided into smaller partitions and stored across multiple systems that are processed parallelly. So your data object, okay, think that here 10 lakh records, here 10 lakh records, here 10 lakh records, here 10 lakh. So they are processed parallelly. Suddenly, if any one goes down, if any system or any slave goes down, right, your data is lost. So how do this? What is that? Spark. It has got powerful fault tolerant model. It can recompute and get it right. So that fault tolerance model separate discussion we have got, but it has got powerful fault tolerant model. And one more important feature of this PySpark, right? Persistence. No need to again and again do the same execution, but no need to perform the same things, right? Operations again and again, right? No need to perform the same operations again and again. So we have got persistence means if they are persistent means available in the RAM. It will be available in the RAM, right? So it can provide its output to the next flows. Yes, it provides output to the other flows. So if I say about persistence feature, means whenever you perform any transformations, right? Transformations, a particular transformation used by multiple flows, see this a Spark is a data flow language. It's a data flow language, right? Yes. So here data flow, but from here the flow is going in this way. So here, if the flow is going in this way, right? So this particular transformation used by flow one, see this first flow, second and third. So these three flows are using this particular transformation. So persist this transformation, make this particular thing available in the RAM only, so that it can provide its output to the other flows, right? Yes, persistence features, right? In-memory computations, lazy evaluated, fault tolerant, persistence, and distributed, and parallel processing, right? Yes, parallel processing. The main feature you can see is parallel processing, right? Within this. So real-time usage of PySpark. If you see coming to this, where exactly this PySpark used in the real-time scenario. Okay. Yes. Any query? So real-time usage of PySpark. In commercial sector, right? So if you talk about it uses Apache Spark real-time processing systems. Banks, if you talk about the bank and other financial fields, using Spark to retrieve the customer's social media profile and analyze to gain useful insights, right? Which can help them to take right decisions. Bank and other financial fields using Spark for retrieving the customer's social media profiles, right? The extracted information is used, right, to just again analyze about the credit risk assessment, targeted ads, and for customer segmentation, right? So Spark, if you talk about this PySpark, right, it plays a vital role even in fraud detections, and widely used in, especially mostly used in ML tasks, machine learning tasks. In healthcare also, right, even within the healthcare. In healthcare, right, it is used to analyze the patient's records along with the previous medical reports data, right, to identify which patient is probably to face this kind of issues, right, even after being discharged from that particular clinic. So using this to analyze the patient's patterns with his history, with his health history, right, just identifying or analyzing or predicting, right? Yes. Even if you talk about, okay, in healthcare, right, one second. And today if you see, even in the entertainment industry also, it is mostly used. In entertainment industry also, it's one of the largest sector, right? Entertainment industry also, it's one of the largest sector which is growing towards online streaming, right? Online streaming. So the popular online, if you see the OTT platform, the famous OTT platform Netflix uses Apache Spark for real-time processing. So to personalize the online movies or web series to it. So it, if you talk about it process approximately like 450 billions events per day, right? That was streamed on server side applications, right? Okay, even this I mean to say that Netflix also using Apache Spark today for this. And even in the e-commerce side, right? E-commerce side, leading e-commerce websites, like if you talk Flipkart, Amazon, etc., all this, they are using Spark for advertising. Even like there are some other sites like Alibaba provides enhanced customer experience and optimizes the overall performance. Apart from this, like even in the tourism industry also, right? Yes. Spark is used here to provide advice to millions of travelers by comparing hundreds of tourism websites. So these are the major things, right? Yes. So even if you talk like why we need to go for Apache Spark as come. So even we have got big data, Hadoop is available, right? Yes. If you talk, observe here, if you talk like PySpark, PySpark, right? Yes. See, observe this one. I'll come back to it. So there was a test conducted previously by Yahoo, right? Yahoo has conducted a test to check the speed of various databases. So by taking a table of 100 TB size, yes, 100 TB size consisting of 1024 columns. Yes, the test or the task is sorting based on 16 columns. And time taken for the different databases. Talk like time taken by the different databases, right? So if you talk about Oracle has taken nearly 3.5 days to process. And if you talk like MySQL has taken nearly 6 days. And we have got some specialized databases like Teradata that's just taken 4.5 hours, right? 4.5 hours. And Netija has just taken 3 hours. Okay, fine. Finally, if you see, if big data Hadoop has just taken like 3 minutes, right? 3.4 minutes, 3.4 minutes. So where is this 3 hours or 3 days or 3.5 days, right? And Hadoop has just taken 3.4 minutes. But if you talk about this PySpark, right? PySpark, right? It's 100 times faster than Hadoop. 100 times faster than Hadoop. Then you see the speed of this Spark, right? 100 times faster means see the speed today like Spark, very high speed processing because of this in-memory computation, data storing within the memory, data getting processed within the memory, right? Because of which we see very huge. So we are going to see, we are going to build, it's a data flow, right? As I said, so we are going to perform some, we are going to trigger some action, then only it's going to get executed. It's going to divide into partitions, distributed across multiple machines, processed parallelly and giving the result, right? So it's 100 times faster than this. So this is what the motivation towards Spark, right? Yes. So even if you see like the PySpark job market, you can just check this PySpark jobs. You can just Google and check. Even you have got a lot of demand for it, and even see the salary packages for PySpark as compared with other technologies, right? The package will be very huge as compared to other things, right? So if you see what I am going to discuss as part of this course, right? When we have got a lot of things I'll be discussing, all each and every functionality of PySpark in brief, in depth, right? Starting with PySpark introduction, this especially for Spark with Python, especially it has got many functions it is providing, right? Especially for Spark with Python, it has got many functions where we don't need to write huge coding. The main advantage of using Python for implementing Spark, Python has got its own advantages, right? Very less code you see, simple syntaxes we see, right? For this, and many modules, wide varieties of modules you can see, right? Many modules are available for it, and we can interactive, we can easily go for interactive mode. And here you see why Spark need for PySpark, and PySpark sessions, PySpark context, Spark context, right? And PySpark RTD, parallelizing, repartitioning, broadcast variables, accumulators, and PySpark computations, RTD computations, uh, RTD persistence features, different persist options, memory and disk options, core computations like fault tolerance model, creation of partitions, groupings and aggregations, and difference between those different types of groupings and aggregations, and various actions and transformations one by one in brief, right? Like no need to write any code, directly we can apply these things. Count by key value, sort by key, union, distinct, joins, co-group, Cartesians, other. And if we see the major advantage we see in PySpark is the data frames. PySpark SQL, most see in PySpark mostly used ones like data frames. Previously RTDs were used a lot, but now data frames are used a lot, right? And making the data structured and using map and multiple expressions. And if you see like SQL context, data frames API, various data frame APIs, and PySpark data frame creation, empty data frame, converting data frame to pandas, and show, PySpark show, row class, column class, select, collect, with column renamed, where, drop, order by, sort, group by, John, union, all right. Many UDFs available, flat map for each sample, pivot, partitioned by, yes, all this. And apart from this, if you go to the PySpark SQL functions, lot of SQL functions like aggregate functions, window functions, data and timestamp functions, JSON functions. And if you talk PySpark built-in functions, well, so we have got lot of functions, each and every function with some examples, right? Yes. String, translate, overlay, to date, difference, month, explode. Yes, map keys, map values, struct, row, rank, dense rank, percentage, percent rank, type from JS1 to JS1, JS1 tuple, PySpark external sources, how to create these things from external, from Hive, MySQL, narrow and wide transformation, addition of new columns, dropping columns, renaming, handling nulls, window functions, yes, yes, and deploying PySpark applications, states and tasks, drivers and executors, building Spark applications pipeline, deploying Spark applications to cluster and tuning and performance tuning, and PySpark streaming concepts, integration with Kafka, and PySpark machine learning library. Everything will be discussed, right? In brief. Okay, it's a 10 weekends. It's so everything, it's a huge syllabus we are going to discuss, right? Many functionalities of PySpark one by one in brief, right? So we don't need to write huge codings here. So it's a 10 weekend batch, like 2 to 2.5 months. We are going to complete it within 2.5 months, right? So yes, yeah, every session is video recorded. You will be getting the recorded video of it. Clear notes you will be getting session wise, topic wise, right? Yes. So even the software will be provided to you. So it will be provided to your Google Drive, yes, and notes to your mail IDs, and also videos to your Google Drives, right? Yes. Any queries from your side, anyone, right? Yes.
Daily, how
See,
many
yes,
hours of
yes,
session?
yes. One second. Akshit, right? So once again I say, right? It's Spark is a execution model, and Python is a language. PySpark is not a language. Python is a language. Spark is an execution model. Both the execution model for implementing or to code, you require a language. So we use. So for example, if you talk machine learning is there, to implement machine learning, we have got many ML techniques are there. Regression techniques, classification, clustering, recommendation, pattern matching, many techniques. To implement those techniques, right, we require a language. So Python is the mostly used in implementing machine learning or data science. Even in big data, like in Spark execution model for processing, for Spark processing, right, we require a language. Coding is done in Python. Yes, yes, yes. Real-time processing, right? Yes. Spark is meant for real-time processing, right? Yes, Gaurav. So, so the rate at which the events are generated at the same rate, the events need to be processed, right? So we require such a kind of technology So where you should have high speed, the rate of speed of generating of the events should match the rate of processing of the event. So Spark is such a kind of technology, right? Lightning fast technology, which at the rate, the what rate the events are generated, at the same rate the events will be processed. At one side, the events are generated. The other side, Spark will be processing the events the same speed, so it can match the speed, right? Yes. So it's for data engineering role, right? Yes, Akshit. So, but don't forget, every data scientist need to have the knowledge about this, right? Where you need to perform some kind of ETL kinds of operation. Yes. So, okay, yes, daily, see, it's not like a daily base, it's a weekend batch, right? It's a weekend batch. So it will be on Saturday and Sundays. Saturday 2 hours, Sunday 2 hours, 4 hours, but later I'll be increasing to 2.5 hours, 2.5 hours. So 5 hours will be getting per week. So if you go for regularly Monday to Friday, it will be 5 hours. But also Saturday 2.5 hours, Sunday also 2.5 hours, right? Yes, it is also meant for batch processing. Spark is meant for batch processing. It's not for online processing, right? It's not for a single or two records or three records. We no need to go for Spark. So for millions and trillions of records, right? For millions and trillions of records, you go for Spark. For one transactions or two transactions, no need to go for this. Millions and trillions of transactions, we go for this, right? Yes, it's for batch processing, right? So here one thing, yes, if you bigger data sets will be taken, right? But not based on the data sets that you are going to process. You are just based on the schema and how we can process it, right? So if you got whatever it is, 5 records or 5 lakh records, the coding is not going to change. If you got 5 records or 5 million records, your coding remains the same, right? Yes, most of the things mostly we go for mostly in Spark, right? Data frames mostly used. Data frames are mostly used, right? Making the data structure, right? Okay, Python is mandatory to know for this course, right? Okay, so even if it doesn't have knowledge on Python, right? Yes, just I'll be briefing you about, right, for some one session or two sessions I'll be spending on this Python before I'll just give a brush up on all this Python. Python is not a kind of technology where you can learn, you can just update by yourself also. Simple syntaxes, very easy to learn, right? Yes, I'll just, before I go with the practical part, I'll just brief you about those things, right? Yes, structured, unstructured, right? So semi-structured, so taking some kind of other data, right? Data, some weblog data, URL data, JSON data, XML data, right? This kind of data also I'll be working with. Yes. Yes, roles and responsibilities, other things, right? And resume building, other things, every at the end of this course, right? I'll clearly provide all those things, right? Roles, responsibilities, and resume building, other things, right? Yes, how you can apply, and some sample resumes I'll be forwarding you. Yes.
Maybe, do we need to complete Hadoop and Spark and Scala course before starting this? Not required.
So here, okay, just basics of HDFS required, basics of HDFS. HDFS commands knowledge is required. No, if other things even are not that much, but even the things, the basics, whatever required for this PySpark related to Hadoop, right? If not possible, I'll just provide you that basic videos of this. You can just go through of those things. If anyone doesn't have knowledge of the basics, right? So not a problem. Only HDFS knowledge, some is required, and some scoop knowledge is required. Means how to pull the data, from databases to HDFS, right? That knowledge is required. So if it doesn't have knowledge, I'll just provide that basic videos of this Hadoop, right? HDFS. Not all the videos, like HDFS and scoop, basic videos of it.
Because
So
currently we are in evening batch Hadoop. So currently we are having Hive.
yes, I can. The
Yeah.
basics of
Okay.
HDFS required. So
Okay.
not it's not 1 day or 2 days. Yes.
Okay. Yeah.
So yes, Manjunath, right? Yes. At the last, I'll be discussing those kind, right? At the end of this course, I'll also give you the knowledge on those things. So in the here, mostly we work with, yes, lambda expressions, lambda things, right? Triggering this lambdas, right? Yes. Yes, Kiran, mind. Yeah, even about in this cloud side also, how it is used and how we are going to use it also. I'll be providing you that knowledge on those things, right? And even you can see PySpark total functionalities, the various APIs of this, right? PySpark, everything in brief, one by one, we'll be discussing with multiple examples, right? So that's the way I'm saying it's 10 weekends. It's not like 6 or 8 weekends, right? It's 10 weekends. We'll be spending more time on this in brief knowledge. You'll be getting the command on this. Even for streaming, even sometimes I'll be at the end, I will be also showing some kind of streaming data, how to work with streaming data, means data which keeps on incrementing, the data which keeps on generating such kind of data using this Flume and Kafka, right? Like how we can integrate like Spark and Kafka integrate some integrations like Spark Kafka integrations, Spark Hive integrations, Spark database integrations, like Spark NoSQL like NoSQL database integrations also I'll be showing during this course. Yes, Panindra, yes. So yes, I'll be showing you how to run this, right? Even on this each weekend, how many hours, right? So Saturday 2.5 hours, Sunday also like 2 to 2.5 hours, right? So like you'll be getting 2 hours on Saturday, 2 hours on Sunday, 4 hours. Later I'll be when I'll go with the practical part, or later in working with Spark SQL. If not required, I'll be increasing to 2.5 hours, right? Yes. Yes. So the timing of this will be like 4:30 to 6:30, right? Yes, 4:30 to 6:30. Saturday 4:30 to 6:30, Sunday 4:30 to 6:30 is this batch timing. So tomorrow also you can attend the session, right? Everyone, you can attend the session to see more on this, right? So just today was introductory session, what we are going to discuss and what is tomorrow we will be discussing in brief more on this. Tomorrow it's not like any duplication of today's, but we'll be continuing from here on to see more on this, right? Yeah. Any more queries, right? Any more queries from your side, anyone? So basic knowledge of Python required, but still I'll be providing that for 2 sessions. Just I'll be briefing you about all this Python functionalities, right? Yes. Yes. At the end, I'll also just show you like how to get this Spark and Kafka integrations, right? Yes. Okay.
Sir, good evening, sir. Hive and Spark with Scala, these are all knowledge mandatory, sir.
So the Hive is okay. So Hive HQL is similar to SQL only, right? Even that some basic means how to create it, how to that knowledge. If you doesn't, if you're not aware, right? So like basics of from Hadoop, what you can take is basic HDFS, basic scoop, and basic Hive knowledge required, right?
But
So
we don't know that when we are providing any classes.
yes, I'll provide some videos. It's not a, it looks like normal SQL only, right? HQL also similar to, HQL is similar to SQL only, right?
Yes, sir.
So how to work with those things before I go with the integration part, either I'll ask you to go to the video and come. If you have got any queries, you can ask me up there. Before I start with those kind of topics, that I'll just, if any prerequisites are there, I'll just provide that step-by-step explanation is provided in that videos, right? So just not all those, some videos, right? Basic videos. Yes, definitely. I was saying, right? You'll be getting great command after this course, right? With all these functionalities, right? RTDs concept, data frame concept, DS streams concept. Right? Yes.
Any cloud knowledge mandatory, no, sir?
Yes. So I'll said I'll also provide you those things right at the end.
Okay.
Yes, yes, even for this. Yes, it is helpful for designing Azure Databricks also, right? For notebooks. So here I'll be showing you in this Jupyter. I'll be different environments I'm going to show you, right? In this Jupyter notebook and Spider ID. There's some IDs I'll be using like Spider ID, PyCharm ID, Jupyter notebook. Yes, and Google Colab, right? And within this VMware also, I'm going to provide these things, the PySpark running on this, where I'll be giving you that VMware where you can see all these components, Spark, PySpark, Spark with Scala, and other all the Hadoop components you can see, right? You can work with it. And okay. So fine. So if I'm done with the queries, then I will sign off for now. Meet you tomorrow, right? Same time at 4:30 to see more discussion on this, right? Yes.
Once you show me that notepad, sir.
Which one?
Notepad, sir.
Yes, yes. 1 second. 1 second. These things I'll be forwarding you, right? No, notes or whatever it's. Okay.
Sir, basic Python is enough, no, sir. Actually, I'm your batch 9 o'clock student, sir. Actually.
Yes, yes. Basic Python is enough.
Mm.
No, okay. No need of total advanced Python. All those concepts not required. Basic Python knowledge, and mostly like you need to have the knowledge of functions, right? So by the time we go deep into this PySpark, okay, you will be completing those things, right? So basic Python is enough. That's enough, right? So for the first first 2 weeks, right, we'll be discussing more on this environments, installations, modes, and RTDs, those things, right? How they are computed, how they are created, those things, right? Yes. Fine.
Sir, one question. What if I miss one or two classes in between? Because it may happen.
So yeah, not a problem, right? Yes. So it's a weekend batch. We might be having multiple. So you'll be getting time only on the weekend. So many people can miss the session. In such case, you'll be getting the recorded video that day itself, right? At 6:30, for example, 6:30 the class gets completed. By evening 8:30 or 9 o'clock, you'll be getting the recorded video session, right? It's only,
Okay.
it's only viewable. It's not downloadable. You can just view it. So if anybody on Saturday, if they're absent for Sunday session, you can be ready with going through the video, right? So every day means every session is recorded. Every session will be recorded. You'll be getting the recorded videos of it. Even if you're
Okay.
absent because of some job timings, if you're unable to attend, or because of some ill health, or because of anything, you can just go to the video. Still, if you got any queries at the next session, at the end of the session, you can spend time for your queries. Yes.
Signing, and you will use Azure platform or AWS or Google?
Pardon? So just I am going to show you this cluster on this cluster, right? How we are going to execute these things.
Are you providing interview questions?
Yes, 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 yes. Many interview questions at the end. Some sample resumes, interview questions I'll be providing at the end, right? Yes.
Yes. Sample resumes in the sense you are providing as per big data
Yes.
resume, right?
Yes, yes. Big data environment.
Okay. Actually, I'm looking for Azure environment. I mean Azure data environment.
Yeah, big data environment only. Just my resumes will be from big data environments, right? Yes. Fine, right? Okay. So I'm stopping here. We'll continue tomorrow. Same timing at 4:30. You can follow the same link to see more on this, right? Yes. Right. Thank you all for your time. Thank you. Yes.
So tomorrow also same time.
Yeah, same time you can follow, same time. Same link, right?
Okay, sir. Thank you, sir.
Yeah. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right?
Yes, sir.
Fine, thank you. So in the last yesterday session, right, just I was briefing you about what is PYSPARK, why PYSPARK, right? So yes. So what is Apache Spark for big data analysis for processing and computation, right? If you see more on this, Spark was developed, the personality who developed, right? Spark was developed by Matei Zaharia, right? In AMP lab. It was open sourced. Spark was open sourced, right? In the year 2010. Spark was open sourced in the year 2010. It was donated to Apache Software Foundation, right? It was donated to, yes, it was donated to Apache Software Foundation. In the year 2013, right? In the year 2013. So it was developed, it was open sourced in the year 2010, and it was donated to Apache Software Foundation in the year 2010, used for big data analysis and processing and computation, right? Used for big data analysis, processing and computation. Why PySpark? As I was discussing, like why PySpark. So before that, why PySpark, right? Why PySpark? Yes. Yes. I defining Spark, right? If I want to define Spark, defining Spark. Yes. I define Spark in 4 lines, right? So 4 to 5 lines. Yes. Spark is a open sourced. Yes. Sorry, there was a connection problem, right? Fine. Now is my voice clear and audible to all, right? Yeah, can anyone please confirm once again? Is my voice clear? Fine.
Thanks,
So
sorry.
Spark, I defined Spark in 4. Yeah, it's an open source distributed execution framework, right? Distributed execution framework cluster computed in-memory computation with parallel process style with parallel process style for large scale data processing right? Yes. So here Spark is an open source distributed execution framework cluster computed with in-memory computation feature uh, and with process style parallel process style for large scale data processing right? Yes. Okay. So Spark can be coded with different languages. Spark can be coded with Scala by default. Actually, Scala by default. But as compared to Scala, right, today like Python has got many libraries, many built-in libraries, right? Even for especially for graph algorithms, machine learning, these techniques, right? And for recursive algorithms. So that's why Python also mostly used. Both the Python and Scala are mostly used, right? Right. And Java also can be used. So multi-language support. Spark is a multi-language support. It can be coded with Scala, Python, Java, and or language. Like or language also, right? Yes. Spark can be coded with Scala, Python, Java, and or language. And if you say why PySpark, right? Yes. It is the Python API, right? It's a Python API to use Spark. So why PySpark means PySpark is the Python API to use Spark. Sorry. So what is PySpark? Is a lightning fast technology. It's a lightning fast technology. Yeah, that is designed right for fast computing. Designed for fast computing, right? Yes. Is the lightning fast technology that is designed for fast computations, right? I can say like PySpark is a demanding tool. It is a demanding tool among the data engineers, right? Among the data engineers to work with bigger data sets. Okay.
Sir, will you share this notepad with us?
Yes, that's why I'm preparing notes parallelly, right? So not okay. This everything I'll be forwarding. PySpark is the Python API to use Spark. It's a lightning fast technology that is designed for fast computing. It's a demanding tool among the data engineers to work with bigger data sets. So next, okay. PySpark used for what? So PySpark used for, yes, distributed SQL, creating data pipelines, ingesting data into database, running ML algorithms, graph data streams, right? Yes. So yes. So using we can also write a data into data. I can create a database table. So from a data frame. So Spark data frame is there. The Spark data frame I can write into a database. So a table gets created. I can read the data from database directly. Spark can read data from database directly without the use of any scoop like, and directly Spark can write into the database, and Spark can integrate with any databases like Spark can integrate with Hive, Spark can integrate with database like MySQL or any other, and Spark can integrate with Hive and NoSQL databases. Creating data, I said Spark is a data flow language, right? So collection of sequence, collection of pipes. At each pipe, either transformation, filterings, groupings, aggregations, or sorting you are going to see, right? Yes. So if you see the various, okay, we have got some PySpark many packages available, right? Yes, as compared with the Scala, right? PySpark packages. Just PySpark itself is a package, and within that we see like sub package PySpark.sql for SQL operations, for data frame creations, many SQL functions it supports, right? And even PySpark is supporting many modules, right? Many modules and functionalities, even for streaming, right? Even for streaming, if you see like a Spark streaming, micro batching, right? Quick results. I want quick results, right? For every 2 seconds, I want some updates. For every 5 seconds, I want updates, right? Yes. And also not only for that, even like Python is mostly chosen, right? Where Python itself has got many modules. Python itself has got many modules, right? For machine learning, like if you see like Pandas, Matplotlib, NumPy, Pond, CP, Scikit-learn. But still PySpark has got, right, PySpark.ml. That's got many modules and functionalities, right? And even PySpark.mllib, right? Yes. Okay. So if you say like Spark plus Python, so Spark is once again I'm saying Spark is an execution model plus implemented by using a language called Python. Spark and Python combined is a like PySpark. Execution model implemented by using a language called Python. Not only multi-language support. So generally, yes, we have got HDFS. So generally, okay, just I'll show you this, right? So this is your HDFS, we say. Hadoop distributed file system. We say like big data Hadoop, right? Hadoop has got HDFS. So Hadoop is meant for two things: storage and processing. Storage and processing, right? Yes. For storage, it doesn't use any database, right? Because databases has got some drawbacks. Databases has got some drawbacks. Means limited storage databases. Most of the databases, no parallel processing. If volume keeps on increasing, right? Means if you see if you want the total amount to be calculated for 10 records or 1,000 records or 10 lakh or 1 crore, if data volume increasing, speed decreases, right? And mostly like we talk about the databases can handle only structured data. So despite of all this, it's not going with the databases for storing its data. It's going with a file system called Hadoop distributed file system. Hadoop is meant for two things: storage and processing. For storage, we go for HDFS. not any database, because I was just saying like you have got some drawbacks with it. So despite of this drawback, still Hadoop doesn't goes with database. It's going with a file system called Hadoop distributed file system. And also for processing, Hadoop used to use MapReduce. MapReduce was widely used. If you see from, if you go back like in the year 2012, 13, 14, 15, 16, right? MapReduce was widely used, but now MapReduce is got outdated because of this huge codings and many lot of programming required for this. So it was, so we are using Spark. So for storage and processing, and for storage HDFS, and for processing, now we are going with Spark execution model, right? We are going with Spark execution model. Spark has got very high speed, right? Spark has got very high speed processing. So computation, right? Storage happening within the memory and processing also within the memory, because of which we are going to get huge, very high speed. So Spark, again, implementation. Spark has got implementation using coding, coded with multiple languages. I was saying like Python, Scala, Java, and OR language. So, but Java is never preferred. Only some less companies like only some companies, only like couple of 1 or 2 companies, right? They'll be preferring for Java, but OR language is never used. Okay. Python and Scala is mostly used. By default, Spark built by using Scala, right? So Java means, I was saying some companies like Value